Name any popular application, online store or airline website, and it's safe to say that their developers use containers. Adobe Photoshop, of course. Dapps.com, yes. Air France, definitely. Creating a container is hundreds of times faster than a VM. This saves time on testing. On the same physical server with containers, it's possible to host 3 times more applications than with VMs, and this saves infrastructure resources. If my story ended here, it would make sense to write an obituary for classical virtualization, but the fact is containers are incredibly popular right now doesn't make virtual machine obsolete. Hi everyone, my name is Pavel Karplay, and in this video I'll be happy to tell you what containers are, what virtual machines are, and why Docker containers won't bury virtual machines. Well, at least in the near future. When you work with a VM as a user, you cannot know that this isn't a physical server. Moreover, you can create a virtual machine on top of another virtual machine instead of a physical server. If you want to create a virtual machine, you need at least 2 things. Server infrastructure, it has RAM, CPU, HDD, which you are going to divide into VMs, and hypervisor, a set of instructions that allows you to create host-based virtual machines. The main thing to remember about virtual machines, they are isolated from each other and like to pretend to be real servers. It requires a lot of resources from CPU, RAM and hard drive. Each VM needs a set of drivers for virtual hardware and usually runs with operating system. A container is not a physical server emulation. It doesn't pretend to be it, and it doesn't have virtual RAM, CPU and hard drive resources. Containers store different parts of the application, libraries and rules for accessing shared resources of the server and the operating system. When we speak about containers, we mean separate processes. These processes are required for web applications work. Thanks to this feature, containers are created in seconds, not in minutes like VM do. They take kilobytes instead of hundreds of megabytes. Containers can be created in batches, hundreds instead of couples of VMs. But at the same time, they do not have such isolation that virtual machines have. Things to remember about containers are speed, lightness, and simplicity of technology for developers. To keep things simple, let's look at an analogy. Imagine that you're a developer, a real estate developer actually, with a piece of land. You have all primary infrastructure connected to it: electricity, water, sewerage, and you have 2 options in your head what to build on this land: 20 townhouses for 40 families or a hotel with 200 rooms. In the first case, you supply electricity to each house and install electrical equipment. You provide water and install a boiler in every building. But when it comes to security systems, each townhouse owner independently takes care of the house protection. In the second option, the guest in your hotel doesn't care about anything, because everything is included in the price. So, which is the best option? Should you build a hotel or townhouses? Of course, there is no correct answer, because it all depends on the tasks. The same people who need townhouses to live with their families long-term may need hotels to settle for a while during the holidays. The same picture is with containers and virtual machines. These technologies do not fight, but kind of complement each other. Let's recall the main features of VMs. First off, it's the ability to get any guest operating system and isolation. And when you have isolation, it's much easier to provide security. For example, a company needs to provide sales, accounting and marketing departments with IT resources. But each department has its own unique needs. The sales department needs a CRM, the accounting department needs an accounting system, and the marketing needs a machine for the website. Operating system should also be different: Ubuntu, Windows, CentOS. One system administrator can effortlessly solve this task. Upon request, he or she will create virtual machines with the required production environments. All these business services will be isolated from each other, so if the website is hacked, it won't affect the accounting software and won't leave employees without a salary due to the server virus. Virtual machines make it easy to set up and secure remote workplaces. In this case, all the computing resources remain on the employer's side, and the employee gets access only to the part he or she is working with. As a result, the level of informational security increases. It's convenient to use virtual machines if the departments within the company have different requirements for OS and software, for website, CRM, ERP, accounting system, or an internal portal. Isolation of the business services are critical to the company. There is no need for continuous integration for any company's project. For example, in the case of the CRM, the most companies install it once and then work for years. When we talk about containers, we primarily keep in mind the development, testing and deployment of applications. Docker is the most popular containerization technology today. Spank the like button if you heard about this technology. Using Docker containers, the environment for different development stages can be configured many times faster than with virtual machines. Some companies run small web projects and do not require continuous integration. Or the isolation of each business service, CRM, sites, databases, ERP, is critical to them. In these cases, virtual machines are quite enough. To create and work with virtual machines, people use VMware vSphere, Microsoft Hyper-V, and KVM. Speaking of containers, number one is Docker, but it's not the only containerization technology out there. I'd love to dwell to another containerization technology, Linux containers, or LXD. LXD works the same way as Docker, only in the case of LXD, not applications but operating system images are deployed as containers. A Linux container looks like a virtual machine, but LXD has several advantages over other tools. LXD containers are faster than virtual machines. Unlike virtual machines, LXD containers do not need to allocate RAM for the OS kernel, because they use the host operating system kernel. The downside of this is that you can only use Linux family operating system, which can be unsuitable for some business processes. The isolation of LXD containers is higher than that of Docker. Let's repeat in which cases this or that technology is used. Virtual machines are relevant for providing persistent tasks in most companies. If you need stable execution of various workflows in a secure environment, then choose VMs. They meet all these requirements. This virtualization is simple and accessible to all. If isolation is important, but the server infrastructure is quite limited, then LXD containers come to rescue. They allow admins to install a Linux guest operating system on containers and get a light version of VM. Docker is a great tool when it comes to software and application development. It saves developers time and eases up the scaling. That's all, guys. If you like the video, spank the like button. And your subscription is the best motivation for me to make new videos. I have tons of ideas on server topics, virtualization and cloud.